Welcome everyone to ATA GTR 2022 Day 1 Track 1. So moving on to our first session of Day 1 Track 1. We would like to welcome Gayathri and Pallavi. Gayathri is working as a principal consultant at ThoughtWorks and Pallavi is working as a quality analyst at ThoughtWorks. Gayathri and Pallavi would be speaking on continuous testing strategies for CFRs. To know more about Gayathri and Pallavi and to see their video interviews, please check out the given links below. The floor is all yours, Gayathri ma'am and Pallavi ma'am.
Thank you.
Thank you.
Let me share my screen.
Sure, ma'am.
I hope the screen is visible to everybody.
Yes.
Good. Pallavi, do you want to start?
No, you can kickstart. I'll continue.
Oh, okay, great. Very warm welcome to everyone to this session. I mean, really great enthusiasm. I could see like 283 participants in the keynote, and I was amazed. I'm really happy to be here, to be very honest, on a Saturday, and that two people across the globe attending the session is really motivating for us. And thank you all for joining. With that, I think the topic is continuous testing for cross-functional requirements. And Pallavi and myself work for ThoughtWorks. Brief introductions. I'm a principal quality analyst. I recently released a book called Full Stack Testing with O'Reilly, member of the Tech Advisory Board in ThoughtWorks India. Pallavi is all. Do you want to kickstart your introduction?
Sure. Thanks, Gayathri. Yeah. Hi, everyone. I'm a lead quality analyst with ThoughtWorks. I've been working as a QA for about 11 years now, but I've also kind of tried out various other roles and also involved in enabling the client teams to set up quality practices. That's a really short intro because there are already intro videos available. I think maybe we could move on. Thanks, Gayathri. All right, I'll quickly touch upon the agenda for today. We will be talking about introduction to cross-functional requirements. What do we mean by continuous testing? And then we'll talk about continuous testing strategy for CFRs. And then we'll pick two CFRs and apply the strategy we've spoken about for those two CFRs. In this case, it is security and accessibility, right? And then towards the end, we'll do a Q&A. Moving on. Introduction to CFRs. I think before we get started about CFRs, right? I think a lot of you must be wondering what are CFRs. Have you heard of them? Not heard of them, right? When we say CFRs, we refer to cross-functional requirements. While some of you might have heard of the term, some of you might not have the term. I think all of us in our journey as a QA would have encountered the cross-functional requirements. We'll talk about what other term is used to refer cross-functional requirements in some time. But before we get to that, I think what we would like to do is, for the ease of the context, we would like to take a very simple, Gayathri, if you could go to the next slide, please. Thank you. So in order to understand everything better, let us consider a very simple three-tier e-commerce web application, right? Like an Amazon or Flipkart or whatever we want to talk about. So we in this architecture, we have a e-commerce UI, we have a services layer, which has three types of services, and we have a centralized database. Now, coming to the services, we have an identity management service. We have an order service, which takes care of updating, creation, and deletion of orders. And then we have the most important payment service, which handles all the capturing the payment requests, refunds, and cancellations, right? This is a very simple web architecture. Right. And now let us talk about CFRs with respect to, with respect to this architecture, right? Now, let us quickly, before we jump to cross-functional requirements, let's quickly take a look at the functional requirements for this. The functional requirements for this architecture or this application, e-commerce application, would be that the user should be able to log in successfully and browse the product catalog. User should be able to purchase an item and it should get delivered successfully. And then as a user, I should be able to log in and manage my orders place in terms of canceling an order or updating an order, right? While these are the business requirements which are usually typically prioritized by the business, are these enough? Right? The question is it enough if I'm able to place an order and if I'm able to manage my orders? Now, let us say that we choose a product and we add it to cart, but it takes more than 2 minutes to add a product to cart. Or I make a payment and all of my details are available on the internet the next day, right? How would you feel using an application like this, right? Because functionally, you're still able to add a product to cart, you're still able to make the payment because the business requirements seem to be met, the app is working as per the requirements. But as a user, would you be comfortable using an application like this, right? This is where the CFRs come into a picture. When we say that, I want to add a product to cart, having a CFR like any addition to cart, any add to cart should be performed within X seconds, right? It talks about how good an experience the user will be getting. Similarly, we should a cross-functional requirement in terms of the payment feature would be that the application transmits and stores the user's personal data and details securely, right? Now let's quickly talk about what we mean by cross-functional requirements. These are nothing but these are requirements that are cross-cutting across the application, right? As evident as the functional requirements refer to the core business services offered by any product to the customers, CFRs typically refer to the executional and evolutionary qualities of an application. We'll quickly touch upon what we mean by executional or evolutionary qualities of an application. When we say executional qualities, we're talking about the behavior of the application during its runtime, such as the availability, authentication, monitoring, security, and others, right? I think recently all of you would have shopped during the Black Friday sale. Imagine the app not being available, and all of us would have been very frustrated, and we would have said we will never want to go and use that particular service again, right? So similar, which is why executional qualities are very important. Similarly, evolutionary qualities are defined as static application code quality. We're talking about maintainability, extensibility, scalability. I think as new geographies are opening up in this world, because the world is becoming smaller these days, we want to be able to spin up instances on demand. Right, all of these are possible if we from the beginning take into consideration the evolutionary qualities of while designing an application. Now let's take a look at some of the critical CFRs for the architecture we just discussed, right? Before we head there, I also want to talk about these are not an exhaustive list of the CFRs, right? This is just what we've done here is we've categorized some of the CFRs as the ones which are applicable to the user interface, some which are applicable to all the layers of the application and the overall application in general, right? While this is not an exhaustive list, there are more than 30 plus CFRs which are spoken about in a lot of books and also available. And I think it also depends on the kind of product you're building and the needs of the business for you to decide what CFRs are applicable for each of us, right? Now let's quickly take a look at one CFR maybe from each of the 3 layers we have defined over here. I think in today's world, accessibility is one of the most important CFRs, because we would want our application to be user-friendly for all different types of the audience that are available out there, right? So accessibility is a critical, one of the critical CFRs that one needs to take into consideration while building any application from the start. Authentication and authorization, I don't really have to talk about that. All of us are aware how important they are. And then we already have monitoring. It is monitoring. We want to be alerted when things are not going as expected, or if we've set certain thresholds, we want to know when it is going below or above, right? And we have a set of predefined errors which we want to kind of be aware even before the end user starts using the application, so that we can rectify those. Some of these are integrated as a part of the application, some are on demand. It all depends on what kind of a product is being built and what is the requirement of the businesses. Again, there's no hard and fast rule that, when you're building something, you need to have all of the CFRs in place. Prioritization as per the business needs is always recommended. Now let's talk about earlier when I started, I said that CFRs or cross-functional requirements are also known as by another name. So a lot of you might have heard the term non-functional requirements as well. I think, and you might ask us, what is the difference? While when we say that cross-functional versus non-functional, the term cross-functional was coined by a colleague of ours, Sarah, and it's also been used by Sam Newman in his microservices book, right? A lot of us prefer using this term because it kind of gives a holistic feeling of the requirements being spread across the application, and that is being built and tested as a part of every feature. That is, the requirements cut across or are spread across every feature that is being built, right? And in general, when you call it non-functional, it sounds a little non-trivial, and we might deprioritize it over the business features, right? Which is why we generally prefer calling it as cross-functional requirements, and that is a term that's picked up. A lot of people have started using it in the last 10 years as well. Now that we've kind of touched upon what cross-functional requirements are, let's also talk about continuous testing, because the topic is continuous testing of cross-functional requirements, right? So when we say continuous testing, what do we mean by it? It is nothing but continuously validating either manually or by using automated tests, every change, every incremental change that is being made by the delivery team, to check if it causes any deviation from the intended outcomes. If things are not working as expected, we kind of hope continuous, and we know that continuous testing will help us in fixing that, right? What do I mean by continuous testing, and where should it start, right? Continuous testing can start anytime. Even typically it starts during the design phase itself, where the prototypes are reviewed and discussed, and some people also do usability testing of the prototypes in order to get feedback. All of this is a part of testing. And during development, again, like we just heard, we have unit tests, we have lower level tests, we have multiple layers of tests, which also give the immediate feedback on every build that is being built. Again, in CI/CD pipelines, like we said, we have the unit integration test, we have the build succeeding or not to be able to promote it to the higher environments. And towards the end, we also have the manual exploratory testing, where we try to break the system, go against and see how things can go wrong, and where is the threshold for the system, right? All of these together in every stage of development of the software enable and contribute to continuous testing, right? When we say shift left testing, what we just spoke is that we are trying to start testing at a very early stage, even before the code is being developed. During the prototype stage, during the analysis stage, right? All of us taking a look at it, giving our feedback is a form of testing. The more we start taking up this approach, the lesser defects will be found towards the end when things are already in production, right? Because you have safety nets at every point in the life cycle of the software going to the production. Continuous delivery, again, is a capability to be production ready at any given point in time, so that the businesses can reap the benefits of going to production early, right, in terms of time to market. One of the ways to achieve continuous delivery is by adopting continuous testing. Now, let's quickly take a look at some of the benefits of continuous testing. Like we spoke about, it prevents, while it helps us in detecting defects early. since all the roles in a team are involved, from designers to developers to QAs, from the BA, everyone, including the client, are involved, it helps us all achieve common quality goals. All right. And again, the collaboration has to be improved because all of us are working together to ensure good quality software. Delivery ownership, again, combined delivery ownership, because again, from the beginning till the end, all of us are working together. Continuous delivery also enables capability to deliver on demand, and it also helps us in achieving the 4 key metrics for a high-performing team. Now that we've spoken about continuous testing and cross-functional requirements, let's take a look at how to apply a strategy of continuous testing for cross-functional requirements. Over to you, guys. Thank you.
Thank you, Pallavi, for that introduction. I think Pallavi gave a good introduction about continuous testing and the CFRs as well. And so this section, I think what I wanted to talk about is provide a simple strategy to think about continuous testing of CFRs. Like CFRs, like we saw in the previous slides, there are many of them. So simply to even break down each one of them or to have an approach in mind for each one of them is actually a task in itself. And most of the time it comes across as a vague requirement, and we struggle to put together a testing strategy for the same. So here in this section, I just wanted to give an overview of how we can approach the continuous testing of CFRs, and not specifically go into the details of each and everything, but the overall approach that will help in guiding the thought process towards continuous testing the CFRs. So first of all, I think take a step back and think about all the software requirements. And if we have to simplify, right, like cross-functional requirements and functional requirements, if we have to simplify, there's this very old model, the FURPS model. It's something that was released in 1960s, I think. So it just gives a framework for visualizing all of the software requirements on a very broad level. So that so I'm just going to use this model to come up with an approach for cross-functional requirements, continuous testing of cross-functional requirements. So that will give us a mindset, an easier approach. So that's the idea. So the FURPS model is nothing but an acronym. It stands for functionality, usability, reliability, performance, and supportability. And what is functionality? Functionality is a category of requirements that can be realized as user flows. So you can visualize it, you can see it as user flows. All the requirements that come that can be put together in that bucket, the functionality bucket. The usability, I think, category of requirements that affects the user's experience. So user's experience in the sense that visually how it is, accessibility, design factors, and all of those things are usability kind of requirements. And when it comes to reliability, like all of the requirements that makes the application fault tolerant are reliability category of requirements. And performance is a well-known term. I think we have, this is like one of the performance KPIs, availability, concurrency, throughput, and all of those things are those requirements related to performance. Supportability, I think we spoke about evolutionary code qualities a little bit earlier, where we said it's the static code behavior, like how is the code readable, is it maintainable, is it a secure code, with all of those things are something that comes under supportability category. So given this kind of a overall simplification of software requirements, we can see what are the testing techniques and testing tools that can be available, because you can see that most of the cross-functional requirements will actually fall into some of these buckets. We'll see that with an example in shortly, but the flow will be, we'll see how there are multiple ways to actually test these buckets of requirements. And the testing, I mean, the age that we live today has expanded so much that we have so many testing techniques and testing tools that are available to us to do continuous testing for all of these buckets. So for example, I think this is the testing techniques that in each of the buckets. So functionality, I think it's well established set of testing techniques that are available. Manual exploratory testing, functional test. So manual, before I go into manual exploratory testing, I think the functional, it's marked under functionality here, but we'll just see it can be used in all of the other areas as well. But for the representation perspective, let's just call manual exploratory testing under functional bucket. Functional test automation, I think when we think of functional test automation, I think it not only at the end-to-end tests or the higher level tests, but it starts from unit integration and everything. Data testing, data is like becoming like the critical piece of the business these days. Data testing, there are several data systems that are in use these days. Each of the data system has its own kind of testing that comes into picture. Usability, there's visual testing. I think everybody would have come across the term where we compare screenshots and see what is the difference, regression testing there. And user experience testing. I think user experience testing is actually on the design itself and not particularly whether it is working on Chrome or whether it is not about after the design has been implemented, but it's about actually the design itself. Accessibility testing, I think we have a set of, we'll come to the set of tools that are available to us, but as you can see, these are separate things that are that cater to the bucket of requirements that fall under that category. Reliability, think stress testing, chaos engineering, and infrastructure testing are all testing techniques that will cater to testing the reliability kind of requirements. And performance testing, like once again, established field, back-end performance testing, front-end performance testing. There are several tools in those areas. And supportability related requirements, right? So architecture fitness tests are there. So when we say architecture fitness tests, like for example, you can actually see whether there are cyclic dependencies, whether a package is independent or is it actually reusable. Those kind of tests can be put at using the architecture fitness test. There are static code analyzers that help us actually do a lot of things. We'll look at some of the tools shortly. And dynamic code analyzers, once again, help in a variety of things in supportability category. And linters, I think, mostly it's like on the static code, you will get to know whether all that evolutionary code qualities can be tested using these kind of testing techniques. So if we have to look at a closer lens on these bucket of requirements and the tools that we spoke about, manual exploratory.
Sorry to interrupt. It would be nice actually if you can just speed it up. We are running out of time, to be honest.
Oh, okay, cool. Great. So manual exploratory testing, I think I'm going to scare. I mean, I'm going to like really speak fast right now. Postman process and all of those things. Functional test automation, I think. Sorry.
Thanks for understanding.
No worries. Yeah. Data testing, I think these are the set of tools that are available for us. And visual testing, user experience testing. I think probably for user experience testing, I'll just highlight some of the tools, right? Like for the design, A/B testing tools and prototype testing tools are there. User Zoom, Optimal, Workshop, all of those things. Accessibility testing, I think these are a set of tools. UI Monkey is kind of like the UI testing tool. There are infrastructure testing tools here. Performance is once again well known. Coming to the supportability bucket of things, there are Arc Unit, Net Architecture tests, check style, as I was saying, static. These contribute to a different set of requirements. Like you can make the code readable. There are security related static code analyzers And DAST is a dynamic code analyzer, which comes as part of ZAP. That's for security reasons. And PA test is a mutation testing tool that will help you uncover some of the scenarios that has been covered in the unit tests. Linters, like for example, these are some of the linters that could actually give you feedback on cross-browser testing itself. So instead of doing it at a very later stage, like an end-to-end test, you can catch all of these things in the linters as early as during development itself. So those are some of the useful techniques that will help us break down the CFRs and put together a continuous testing strategy. So maybe let's take security for that matter, security, and apply that testing techniques and tools, and visualize how a continuous testing strategy for security might look like. So if you take security as a CFR, one example, I think we can see that security can actually manifest itself in some of these ways. So we can see functional flows, like for example, a bank account can be viewed only by the respective account owner and also by the bank account manager, but with different privileges. But it will be like visualized in a user flow, and you that is something that security manifests itself. And then security also manifests in the reliability category. When there are potential threats, it should be fault tolerant. And then supportability related, there are some supportability angle to security as well, where there are the evolutionary code quality. The code should not have known vulnerabilities. So I'm just rushing through a bit here, but I hope the concept is clear that when we take a CFR, it manifests itself within these buckets of categories of requirements. And the job is to see in the context of the application where the requirements fall into, and apply the testing techniques and tools and put together and search for the tools relevant to that particular CFRs and put together a continuous testing strategy for that particular CFR. Like for example, if we have to cater to security testing and take all the testing techniques that we spoke about, from functionality, reliability, and supportability, like static code analysis and everything. So you will see the continuous testing strategy we can put together for security, something like that. Use a SAST and SCA tool for during development, pre-commit hooks, and then functional automated tests for functionality related stuff, static code analysis, and then vulnerability scan, DAST. And manual exploratory testing, once again, I wanted, as I mentioned earlier, even though it is in the functionality bucket, there are a lot of things that manual exploratory testing can uncover, even in the CFRs area. And that's one of the key component when we are actually putting together the continuous testing strategy. And then release pen testing, and there are RAS tools to give that reliability component. RAS tools are something like twist lock and everything, which monitors the patterns of incoming requests that comes in. If there are some attacks that are happening, that will help you prevent. So those kind of tools are available, but the techniques, as you can see, it's the same set of techniques that will be there. For each particular CFR, there will be a separate tool that will be in that particular testing technique. So that's one example. The other example that we can take is for accessibility. I think accessibility, once again, we can see that it can actually fall into these three buckets of requirements. Like there'll be functional category of requirements, like we'll have, let's just say the functional flows, like videos are there, and the transcripts need to be there for video. That's an important accessibility requirement. And then usability part, I think we need to make sure that all the users with disability should be able to use the application, which means that all assistive devices needs to be integrated well and tested for. And then the supportability aspect of it, where the code needs to support all the integration with the assistive devices, which means all text needs to be there, the images needs to have a description, all of those things needs to be tested for. So this is how the accessibility related requirements will manifest itself within this framework of FURPS model. And once again, if we have to pull in all the testing techniques that are available under functionality, usability, and supportability, and find tools that are relevant to accessibility for that particular technique, then your Accessibility continuous testing strategy will look like something like this. So accessibility testing actually needs to start from design and analysis, and even for security, it needs to start from design and analysis, where a threat modeling exercise needs to be done during the design phase. For accessibility, I think we have to actually think about the consistent layout and all of those things. It starts from there, the design part. The during development, static code analyzers, runtime checkers, and then once again, functional test automation, as we spoke about functionality related stuff. And then we have manual exploratory testing, and then we go with the release testing. So this is like 2 examples to say how we can break down CFRs into smaller chunks and be in a position to look for options to put together a continuous testing strategy. Hopefully that came across well, and this is something, the content is from the book that I wrote recently and released recently. So coming to the summary part, I'm not sure, do we have time?
Sorry, guys, actually we already crossed 10 minutes.
Cool.
So you can
Okay.
just give an overview.
Okay, cool. I think that's the key takeaways. I think CFRs define the executional and evolutionary quality. It is as essential as functional requirements and to deliver high quality product. So use the FURPS model to visualize the CFRs. That will help to simplify the CFRs instead of it being really vague. And the continuous testing of CFRs helps in achieving high quality product application.
Okay, thank you.
Thank you.
Yeah, thank you very much, Gayathri, and congrats for your book.